and welcome to our final topic, 4.6.
Radicals! Ready! Oh no! They're dividing!
We're going to be dividing some radicals as well. Now, I've got these little quotation marks around dividing radicals. We are dividing, technically, is what it's being called, but what we're really going to be doing is simplifying some radical expressions that happen to involve division. And we'll see what we have to do there. That'll be explained in a moment, but first, let's take a look at some rational fractions. These don't have any radicals in them. One's 5/3, one's -1/2. Take a moment, see if you can write down some equivalent fractions. So other fractions that are the same as these ones. And consider just how did you get them. Pause this video because I'm about to go on with things. So pause, write down your equivalent fractions. Whoop, here I go. I'm going to say that 5/3 is also equal to 10/6. And I'm going to say that they're equal because I get that by multiplying this by 2/2. Alternately, I could multiply by something like 3/3, in which case I would get 15/9. So that's also equivalent. In fact, I could multiply by, I don't know, what?
-5. Oh,
no, I chose 12. Yeah.
Do -12.
A non-baker's dozen. So anyways, 60/36. Maybe you got one of these, maybe you got a couple of these, who knows? But the key is they are all equivalent. We can do same to this. I can multiply by, so what did you say before?
-5.
By -5 over -5?
Yeah.
Sure. In which case I would get, oh my gosh, there's negatives all over the place. I'm doing it this way. Over -10. Which could be simplified, but that's beside the matter. That's equivalent. Or I could multiply this all by just a straight up 2/2, I think I did in the last one, which gives us -2/4.
What about 10? Multiply 10/10.
Sure, yeah, I could do that. Multiply by 10/10, which gives us -10/20. So those are all equivalent rationals. These are all equivalent over here, and these are all equivalent over here. How did we get them? Well, we will get equivalent fractions by just making sure we multiply both the numerator and the denominator but we multiply them by the same value. That's how we get equivalent fractions.
Okay, so that's all well and good, but how does that have to do with radical expressions? Well, technically, we can do the exact same thing even with a radical expression. So if we had some sort of fraction that involved a radical, we can multiply the top and the bottom by the same thing to get an equivalent radical expression. Now, you might be thinking, really, what's the point of turning 5/3 into 10/6? Right? Like, don't we always just want to simplify and get everything as small and simplified as possible? Well, the answer is yes. But when we're dealing with radical expressions or fractions that involve radicals in them, it's technically improper or poor math form to have a radical in the denominator. Right? So we are trying to rationalize the denominator to ensure that the radical is gone. We can end up with a radical in the numerator, that's okay, but we don't want to have that radical in the denominator. And now we might be thinking, well, how do we get rid of that radical in the denominator? Well, I'm glad you had that thought and asked in your head because I heard it. Well, if I'm taking a look at, for example, this radical expression here, it's the fraction 5 over the square root of 3. Now, if I look at this, how do I get rid of that root 3 in the denominator? Well, I can see, or I know that if I take the square root of 3 times the square root of 3, I know that I get the square root of 9, and the square root of 9 is 3. So if I take a square root and essentially square it or multiply it by itself, I end up with just a whole rational number, which is equivalent to whatever the radicand used to be. Right? So if I had like I don't want root 4, that's just 2. Root 5, if I multiplied that by root 5, I just get 5. Same thing, root 17 times root 17, that's just 17. Right? So if I take that piece of information and I know, well, if I just multiplied that square root by itself, I could get rid of that radical, well, that gives me an idea. If I multiply both the denominator and the numerator by that same radical as to get rid of that radical in the denominator, well, that would allow me to have an equivalent radical expression. Because just as Mr. A said before, as long as we multiply both the numerator and denominator by the same thing, it's A-okay. Alright, so let's take a look. If we wanted to look at this radical expression, 5 over root 3, my end game here is to get rid of that root 3 from the denominator. I don't care about the numerator. Denominator is my number one priority. So I have that same expression, and to get rid of this radical there, I'm going to multiply it by itself, by root 3. Well, if I multiply it by root 3 in the bottom, I also have to multiply it by root 3 at the top, because this whole thing is like 1, and multiplying it by 1, just as we saw in measurement and unit conversions, doesn't really change anything. Just changes what it looks like. Now, if I take my numerator, 5 times root 3, I end up with 5 root 3. And that's pretty dope. And my denominator, root 3 times root 3, is just going to be 3. Because remember, that gives us root 9, and root 9 is just 3. And this is our whole goal here. Our goal is to get to a point where our fraction no longer has a radical in the denominator. Now, this is all well and good. Sometimes we might find that that radical isn't fully simplified. So we do all of this, we end up with our final answer that doesn't have a radical in the denominator. We're pretty happy about it. But then we're like, oh, hey, did you also notice that that radical could be simplified? Well, shoot. Now we have to go ahead and simplify that radical as best as possible. So looking at this next example here, we're going to look at this guy. So 2 root 3 over 3 root 6. And again, I'm only really prioritizing that denominator. So I am going to do what I can to get rid of that radical in the denominator. Right now, my denominator has a root 6 in it. So to get rid of, or to rationalize that denominator, I'm going to multiply it by root 6. And if I do that at the bottom, I kind of have to be fair, so I have to do it on the top as well. Notice that we had this root 3 up here. I could care less about it. It's in the numerator. It's not my number one priority. I only want to get rid of that radical in the denominator. So that is why I chose to multiply both the top and bottom by root 6 and not by that root 3. All right. As I do this, my numerator becomes 2 root 18. And then my denominator becomes 3 times root 6, which is 3 times 6, which is straight up 18. All right. Hopefully, so far we're on the right track. Now, if we take a look here, in our numerator, we have 2 root 18. And it's okay to have radicals in our numerator, because again, the whole purpose is just to get rid of them in the denominator. But root 18 can be simplified further. right? We know that the factors of 18 are 9 and 2. 9 is a perfect square. So we could think of 2 root 18 as 2 root 9 times root 2, which is 2 times 3 times root 2, which is 6 root 2, which we can see happen over there. Now, maybe there should have been an extra step. That's okay though. But if we're taking a look at this step here, maybe I'll write 6 root 2 over 18. Great, our radical is simplified as best as possible. That is absolutely fantastic. But look at those whole numbers. 6 and 18 can be reduced. So 6 over 18 can be reduced to 1 over 3. So you'll notice on this next line here, we end up changing that 6 to a 1 and the 18 to a 3. But we never actually write those ones when they're in front of a radical. So instead of having 1 root 2 over 3, we have just root 2 over 3. And we're going to take a look at a few examples. We're going to start off fairly easy peasy, and then we'll work our way up. And hopefully this all makes sense as we go.
Whenever you get the instructions for these questions, it might say something like rationalize the denominator. It might also just straight up say simplify. It might even just say divide. Regardless of which one of these three it says, the task is always the same. That we're going to make sure that this denominator is rational. So, hereabouts, the only way I can get that denominator to be rational is to multiply it by root 2. And if I'm multiplying the bottom by root 2, I'm multiplying the top by root 2. What does that get us? Well, 1 times root 2 is just root 2. Root 2 times root 2 is the root of 4, which is 2. This is done. Do not go further. There's nothing else we can do with this. We can't say that this is like root 1 over 1. That is a common mistake that I have seen, and I would hope that I don't see it again. But if I emphasize this enough that this is done, there is no more division to be done here. There's no other way to reduce that. It's done. It's done. I think it's done.
I think it's done.
It is done. You can try all these next examples if you want. We're going to go ahead as usual, but feel free to pause. Try them yourself, see what you can do. Some of them might look like they're a little bit of a doozy, but see what happens. Ciao! So my denominator is root 3. In order to rationalize the denominator, I need to multiply it by root 3 again. I'm going to multiply the top also by root 3. On the top, root 2 times root 3 is root 6. On the bottom, root 3 times root 3 is just 3. And this one is done as well.
Again, reminder, we cannot simplify this to root 2 over 1. That is not allowed, even though you're like, hey, 6 and 3 have common factors. Root 6 and 3 do not. Okay, so that is not allowed. Whole numbers with whole numbers, radicals with radicals. All right. Taking a look at this next example. So I'm looking at 2 root 5 over root 2. I only care about rationalizing the denominator. My denominator has the radical of root 2. So I'm going to multiply both the top and the bottom by root 2. When I do that, in my numerator I get 2 root 10. And my denominator I get 2. Now this I can actually simplify because again, whole numbers with whole numbers, radicals with radicals. Looking at my whole numbers, both of those share common factors. In fact, they are 2 and 2 can be reduced to 1 root 10 over 1, or really just root 10, right? Because this here is not fully simplified. We never write 1s as coefficients. We never write 1 as the denominator. So we just end up with root 10. This is very similar to something like 2x over 2, right? where the 2's, the whole numbers, can interact to be like 1x over 1 or just straight up x in the same way. Alrighty. This next example. So here I have root 5 in my denominator. I want to rationalize that, so I'm going to multiply both the top and the bottom by root 5. So my numerator, I end up with 10 root 5. My denominator, I end up with 3 times 5, which is 15. And again, looking at whole numbers and whole numbers, 10 and 15 can reduce to 2 over 3. And of course, I still have my root 5 there. So I will end up with 2 root 5 over 3.
Whoa, this one has a bunch of things going on top. How am I going to handle it? The same way as we've handled all of the rest of these. And that's by looking at the bottom. Okay, so we've got root 5 on the bottom. We don't want the bottom to be irrational. So I'm going to have to multiply it by root 5, which means top is getting multiplied by root 5 as well. And when we do that, there will have to be a bit of a distribution. So bottom is just the usual. Root 5 times root 5 is 5. But on top, we have root 5 times root 2, which is root 10. And then we have root 5 times 1, which is just root 5. I wish this could be simplified further, but alas, it cannot be. So it's done. And I'll scroll over to the right. Whoa! Do I multiply by 3 root 2? And this was covered earlier in the day. In fact, just before I started speaking, really. So no, I'm not going to. I'm just going to multiply by root 2. And if you multiply by 3 root 2, that's okay. As long as whatever you multiply the bottom by, you're doing same on the top.
Although if you do multiply by the 3 root 2, you'll have some extra simplifying work to do at the end.
Yeah. So save yourself some steps, save yourself some time, be a bit more efficient, and just multiply by the bare minimum. Well, on the bottom, we have 3 root 2 times root 2, which is 3 times 2, which is 6. And on top, root 2 is multiplying root 2, so root 2 times root 2 is 2. And we're also multiplying root 6. Root 2 times root 6 is root 12. And I can see there's some simplification to do here because root 12 is not as simplified as it can be. All right. Well, somewhere on the side here, I'm going to say that root 12 is equal to root 4 times root 3, which is 2 root 3. And with that knowledge, I'm going to say this. And for my final step, the parallel is like saying that we've got 2 minus 2x over 6. And we can divide all those by 2 to give us 1 minus x over 3. Just instead of an x, in this case, we've got this root 3 kicking about. So we're going to have 1 minus root 3 over 3. So I've divided all the whole number components by 2.
All right, so this example is done. I want to just write a side random, not including what Mr. A just did, work example on the side here. So, for example, if he had, rather than 2 minus 2 root 3 over 6, he had 3 minus 2 root 3 over 6, he would not be able to simplify this further. No. Okay? And this is a very common mistake that we see made all of the time. If we want to simplify this, we have to look at all of our whole numbers, and they all have to be divisible by the same thing. So in his example, they were all divisible by 2, and that was fantastic. So he was able to go ahead and simplify them. In this case, these two share a factor, and these two share a factor, but 2 and 3 do not have a factor in common other than 1, right? So in order to simplify an expression such as this, we need to make sure all of our coefficients or all of our whole numbers are divisible by the same thing. I don't know why I drew such a giant bean-looking shape.
Oh, I thought it was like an eggplant.
Right, but she gone. All right. If you have not yet paused, I'd like you to pause and try these last 2 examples on your own.
I dare you.
Well, now you got to do it. Actually, you don't. You have autonomy. But here we are, and looking at this next example here, I'm again only caring about the radical and the denominator, that root 5. So I'm going to multiply both the top and the bottom by root 5 so that I can help rationalize that denominator. When I go ahead and multiply my denominator, so 5 root 5 times root 5, that gives me 5 times 5, which just straight up gives me 25. Okay, and if you don't feel comfortable doing that all in one step, you want to write that down. So maybe you go, I'm just going to go 5 times root 5 times root 5, and then you go to 5 times 5, and then you go to 25. That's totally cool. But you're more than welcome to go straight to that 25 piece there. For my numerator, again, because there's 2 terms separated by this addition sign, I have to distribute that root 5 to both of them. So my first term, root 15 times root 5, that will give me, root 75? And then my 2 root 10 times root 5 will give me 2 root 50. My line was a little bit too short. Right, because again, whole numbers times whole numbers, radicals times radicals. Now, if I'm taking a look at these dudes, I realize that my radicals are not fully simplified. Right, so 75 can be written as root 25 times root 3. And 50 could be written as root 25 times root 2. And of course, I still have my 25 at the bottom. Just a reminder, we can't cancel these guys out because root 25 is not the same as 25, right? Because 5 is not the same as 25. So please, please, please do not do that. But I can see that I'll have 5 root 3. I will have 2 times, this guy will be 5. So 2 times 5, which gives me 10 root 2 over 25. And now to decipher if I'm able to reduce or simplify further, I'm looking at all of my whole numbers, 5, 10, and 25. Do they have a common factor? Yes, they do. They are all divisible by 5. So my first term just becomes root 3. My second term becomes 2 root 2. And my denominator just becomes 5. Last but not least, again, I'm only concerned about my radical and my denominator. So if there's a root 2 there, I'm going to multiply both the top and the bottom by root 2. Right? Nothing's different than what we've done before. If I'm dealing with my denominator first, 4 root 2 times root 2 will be like 4 times 2, which will just be 8. And again, take that in as many steps as you need to. Do work on the side. Do what you need. In my numerator, because I have 2 terms separated by this addition sign, I'm going to distribute the root 2 to both of them. So I have 2 root 3 times root 2, which gives me 2 root 6. I have root 10 times root 2, which gives me root 20. And here we have it. Looking if I'm done yet, I'm not quite done because even though root 6 is fully simplified, root 20 is not. So root 20 can be written as root 4 times root 5. And root 4 times root 5 can be written as 2 root 5. And now that I've gotten to this point, I'm looking, well, look at all of my whole numbers. Are all of my whole numbers divisible by a common factor? That is, in fact, true. They are all divisible by 2. So 2 root 6 just becomes root 6. 2 root 5 just becomes root 5. And 8 becomes 4. All right. Questions like these sometimes take a little bit of practice. Know that the steps are the same for each one, but even though the idea behind it is all similar, you're really combining a lot of the skills that we've learned throughout the unit, right? In this question alone, we are combining the skill of rationalizing the denominator. We're combining the skill of multiplying radicals. We are combining the skill of creating mixed radicals. And then as well as simplifying them, right? So there's a lot of skills that you've learned throughout that all kind of come together in this final section. So if you're feeling a little bit overwhelmed, that's okay. It'll take a little bit of practice. And luckily for you, oh baby, we got some practice right here.
Nice.
So give it a whirl and check that out. Last topic.
Woo. Well, I mean,
no, last section, I guess.
Oh.
But you know what that means? Quiz point.
Woo.
Test time.
Yeah.
Review.
Nice.
But that's it for us for chapter 4.
Wow.
You know, it's been a slice.
It's been radical. Never gets old. Nah, maybe it does.
Not in
Just
our time.
like me. What?
All right. Adios, muchachos.
Peace.